For decades, celery has been relegated to the bottom tier of the produce aisle. It is a mandatory sidekick to hot wings, a zero-calorie snack, or a garnish defined primarily by its high water content and fibrous texture. This reputation contrasts sharply with the mechanics of hypertension. High blood pressure is a complex failure of the cardiovascular system that usually requires targeted synthetic pharmaceutical intervention to stabilize. A look at the microscopic cellular structure of a celery stalk shows a collection of active botanical compounds rather than just empty fiber. Researchers have identified specific plant chemicals in these cells that utilize the same mechanical principles found in several major classes of blood pressure medication. Inside the bloodstream, this vegetable initiates specific biochemical changes in the human cardiovascular system, bridging the gap between a dietary choice and a medicinal tool. Hypertension is often driven by excess sodium. When the body hoards salt, it must also hoard water to dilute it, which inflates total blood volume and increases the physical pressure against vessel walls. Celery stalks contain high levels of potassium, while the seeds are concentrated with a compound called NBP. Both function as natural diuretics. These elements signal the kidneys to filter the blood more aggressively, isolating excess salt and water to be flushed out of the body through urine. This process mirrors the action of hydrochlorothiazide, a common prescription water pill used to reduce the amount of fluid the heart has to pump. By reducing total fluid volume, the vegetable acts as a mechanical pressure release valve for the circulatory system. Beyond fluid volume, blood pressure is also determined by the flexibility of the blood vessel walls. Rigid, stiff vessels make it significantly harder for blood to circulate. When calcium enters the cells of the vessel walls, it triggers a physical contraction. This constricts the passage, increasing friction and internal pressure. Celery compounds apigenin and NBP act as natural calcium channel blockers, physically occupying cellular receptors to block calcium. The vessels are forced to dilate and relax, mechanically widening like amlodipine. Apigenin also enhances ACE2 proteins, which dismantle constricting hormones into harmless molecules, mimicking ARB medications. Through these combined actions, celery expands the physical diameter of the vascular highway, allowing blood to flow with less resistance. To see if these chemical pathways lead to measurable results in humans, researchers conducted a double-blind clinical trial in 2022. 52 participants with hypertension took either 4 celery seed capsules or 4 placebos daily for 1 month. Trial data shows the celery seed group experienced a sharp systolic pressure drop of 11.08 millimeters of mercury compared to the placebo. Diastolic pressure also fell 6.54 points. The celery group even reported secondary benefits like improved sleep and easier breathing. The clinical data demonstrates that the plant chemistry observed in the lab translates into measurable cardiovascular changes in a human population. Applying these findings to a daily routine does not require an extreme or unsustainable diet. Medical experts often integrate these plant-based mechanics through the DASH diet, which focuses on consistent, moderate vegetable intake to manage hypertension. The serving size required to trigger these effects is relatively small, just half a cup of raw or cooked celery, or half a cup of celery juice. However, because these botanical compounds are biologically active, they require a specific medical precaution, particularly when taken in concentrated supplement form. If you are already taking antihypertensive drugs, high doses of celery can stack with your medication. This can cause blood pressure to drop too low, leading to hypotension. The clinical and chemical evidence suggests that celery is biologically potent enough to warrant the same caution and professional consultation as a standard medical prescription.